Great job getting the quiz question right, and now let's move on to the final part of the tutorial, Staggered Symmetric Passing Siteswap, where both jugglers do the same thing at different times. First, let's look at a 7-object 2 count, 4p3. Note that whenever I'm throwing a pass, a 4p, Emily is throwing a 3, and vice versa. This can definitely be tricky to see, and you may want to watch this pattern in slow motion. The same can be said for a 7-object 4 count, 5p333. Now let's move away from familiar patterns. This one, 4-3p-3-0, can be found by using what's called a Prešák transform. This is where you take a solo siteswap, add half of the period to any of the digits, put a p on that digit, and you have a passing siteswap. In this case, we took the solo pattern 4-1-3-0 and added half of the period, 4 divided by 2 equals 2, to the 1. We then put a p on it, so it became 4-3p-3-0. Prešák transforms are remarkably deep, and I can't cover them fully in this introductory tutorial. Instead, I've posted a link in the description. Check there if you're interested in more details. Here's another example of a pattern you could come up with using a Prešák transform, 4p4-1-1. It works off of the base siteswap 2-4-1-1. We then took half of the period, 2, and added it to the siteswap digit 2 to get 4-4-1-1. Then put on the p and you're good to go. Finally, we have one more topic to discuss. Staggered symmetric passing siteswaps with non-integer values. You may notice a couple minutes ago that a 7-object 3 count and ultimates were conspicuously omitted. First, let's look at 7-object ultimate. This has the siteswap 3.5p. One way to convince yourself that this is indeed the right siteswap is by thinking about how the objects are being shared. Each juggler is responsible for half of the objects, and there are a total of 7 objects. Since we're only making one type of throw, and it's a pass, the siteswap has to be 7/2p, or 3.5p. Using this sharing reasoning, we can find out how many objects a siteswap pattern requires. If we take the average of the siteswap, and then multiply it by the number of jugglers, we get the number of objects required. In this example, taking the average is fairly easy, 3.5. Multiply by the number of jugglers, 2, and you get a pattern for 7 objects. Looking at this next pattern, 5.5p3333, we find that the average is also 3.5, and since there are 2 jugglers, the pattern is for 7 objects. But how do you throw a half-integer siteswap? Really what this means is that you and your partner are throwing half beats apart. Let's look at this example, 2.5p. The first thing to notice is that Emily and I are never throwing at the same time. In order to make this happen, one of us needs to throw crosses, and one of us needs to throw straights. This is how you'll find that all odd-numbered ultimates are. One partner throws straights, and the other throws crosses. Here's one of my very favorite passing siteswaps. Click the siteswap that corresponds to the pattern that we're juggling.